All right, so someone wanted to say, oh, can I see your face as we're doing this so I can make excited statistics expressions? So welcome to another exciting statistics video. What I have up on the screen right now is this. CDC final ... I want you to open this. It's on the iDrive, and you'll be able to get to the document. We're going to go through and write a little bit of a paper answering these questions. So the first thing you have to do is open up the link, hyperlink, exciting wait. Okay, so now we have the hyperlink open. And this is the Center for Disease Control and Prevention. This is where I got the data. This is the somewhere in here on this website. I have the there it is, National Health Youth Fitness Survey. There's all sorts of interesting places and all great data that you can get on the National Institute of Health website. It's all open source, all free data. And so you can look around, but this is the basic place where I get the data. So your job is first, the data file is actually on the iDrive as well, but is to tell me about the data set. How did they collect data, everything else. You find that all on the website. Then we're going to go through and answer some very specific questions to tell someone about the data. Okay, so when you sit down and tell someone about the data, then you can actually go through. I just got an email from someone looking for the video that I'm recording right now. So I was going to reply to her. Oh, that was stupid to click on that. Oh well. So let's just go through and answer some of these basic questions first. And after I go through and answer some of the basic questions first, then we'll go into some more of analysis level. So the first question is how many subjects in the sample, in the data set. Okay, so we'll go back and here's the data, Center for Disease Control data. Okay, we'll make it fit the little window. So now in the Center for Disease Control data, we can look at the variables. This gets a little bit obnoxious. You can scroll down. There are 100-something variables. If you're using the student version, it won't work because it's too big. 216 different variables. And so the easiest way to look at the number of subjects, well, is to make a very simple graph. So we can let's make a very simple histogram. Okay, and we can just let's look at the height of all of this data. We have 109,000 people. Look at the height, almost perfectly normally distributed. It's because we have 109,000 people. We can go do the weight, do the same thing. And we get 109,000 people. You notice there's a bit of a floor effect. And the data is slightly positively skewed because people can get heavier, but they really can't get that much smaller. Okay, so then, looks all well and good. There's a much better way to answer these questions. So let's go back to the questions. Okay, how many subjects, what's the breakdown of males and females, and what's the breakdown of ethnic identifications? All three of those we can easily do with one crosstabs. So I'm going to go to Analyze, Descriptive, and Crosstabs. So let's look at short attention span. How many subjects? Okay, so males and females and ethnic identification. So let's go to males and females and ethnic identification. Let's use 4-level race as opposed to 7-level race, which we'll talk about in class. Make some bar charts and statistics. We're going to look at chi-squareds, continue, and hit OK. So right now there's a total of 170,000, 98% of the people. There's 2,000 people that are missing, so total is 173,000 people. Wow. Okay, so when we look at, there's 34,000 white females, 21,000 black females, or African American, Hispanic, Latino, 23,000, other races 7,000, for a total of 86,498 females. I think I don't have to read the rest of those. Okay, there's differences in the ratios, so we look at our bar charts and we can see that For males and females, the ratios are about the same number of males and females. So in this particular graph, this one little crosstabs, we answered this entire question. So you're not going to paste all the data there. You're going to tell me what it says. You would write a sentence. There are so many 173,000 subjects. So and so are males, so and so are females, and different identifications. It all is in the chart. You can easily see it in the chart. Okay. So now this one is asking, has the amount of males and females changed over the years of the survey? So we need to look back at the data and say survey year. 4-digit year of survey, that's easy to understand. And males and females. So if I'm asking count, it's crosstabs again. Descriptive, crosstabs, and I'm going to change ethnicity or race over to 4-digit year of survey. And my answer is, well, yes. So we go back and look, and in 1991, 6,000, 8,000, 5,000, 8,000, 7,000. I don't have to keep reading all of these. But you can actually see the breakdown. That answer is the answer for the question. I just got an email from my interest protection to psych students. Okay, moving on. There's the answer. Has the amount of ethnic identifications changed over the years of the survey? Let's find out. Analyze, descriptive, crosstabs. Let's get rid of male and female, and let's add race, ethnicity. And here it is. And when you look at Caucasian, Black, African American, Hispanic, Latino, you can see that there has been some spikes and decreases and changes. You notice in the last couple of years, 2009, 11, 13, 9, 11, 13, 9, 11, 13, you notice there's a general decrease overall in the population. Okay, so that's great. Now go back to our thing. Has the mean weight of freshmen going to high school changed? Because I'm not asking for the amount, I'm asking for weight, I have to make an error bar graph. So has the mean weight of freshmen going to high school changed over the years of the survey? So I have to look for weight and freshmen. So I'm going to go back, and whenever it asks for a specific group, I'm going to look at my codes here for grade. Freshmen are coded as 9, and so a 9th graders are this variable grade equals 1. Okay, so we're going to go to data and select cases. Look at the camera. If grade equals 1. I just selected, and you'll look at the syntax, I just selected for freshman. So now I want to make a graph of short attention span weight, years of the survey. Okay, so let's see if freshmen are actually getting heavier. So we'll go to graph, and because I'm displaying means, we make an error bar graph. Okay, we're going to make a simple error bar graph. Okay, and then I'm going to look at years of the survey, 4-digit years, as my category, and my variable is going to be weight. Very nice. And I'm going to look at this and see that 99, 2001, something's going on with the weight. Between 2007 and 2009, drastic shift in weight. Maybe this is because of the economic boom, and this is because of the economic bust. Not sure. Okay, check. The weight of sophomores going to school changed. Great. So I'm going to go to data, select cases. If grade equals 2. Continue. Okay. Graph. Definitely need sound effects on this program. Notice I'm not changing anything. Click, click, click. And here's sophomores. Oh, maybe there's just a bunch of light freshmen that one year. Okay, and then why don't we just do the other 2 years? Seniors, we don't care about juniors, it seems. Oh, I just did juniors. 4. Continue. Okay. Come on in. All right. Sorry, someone came to the door, and then I went and got a TB test. So now I'm back. I've selected cases for senior, and now I'm going to make the same graph. All I have to do is just go back to error bar. If you have this saved in the syntax, you just hit run again, and it's perfect. But I'll just do it the clicky way. And oh, interesting. So something's interesting going 2008, 2009, but the effect seems to be gone away. The 4-digit years of surveys. Huh. Interesting. So maybe something else is going on in 2008, 2007, 2009, something different, because evidently it's not there for the seniors. Interesting. Okay, it's not really interesting at all. Let's go back to the analysis. So, do the 4 ethnic identifications have the same changes in mean BMI across years and grades? This is a big deal, because you're going to have to do a lot of selecting cases and make a lot of graphs to answer these questions. It's the same basic thing we just did up here. It was super simple to make these 3 graphs. So now we have to do the same thing, except we have to select for each ethnicity and each grade. Not too bad, not too hard. It's just going to take some time. You have to kind of stay organized. So you have to kind of make sure you test what you're actually doing. So first one we're going to do is we're going to look at whites and then other ethnic identifications. So black is not the greatest term, so because it's more of a racial term versus African American, Hispanic, Latino, and we'll throw everybody else into other. That's how the graph is. So if I actually go up and go back and look at my graph, now I've actually made that. Let's look at this graph real quick. So I just made the graph of ethnicity. There it is. So we have about 50-50 Hispanic Latino, a little bit of Asians, and then less than 50% of Americans are 50-50. Let's actually see the actual numbers here. Or if you want to do percentages, we go back and do the same pie chart for level race, and let's change it to percentage. And there we go. So it's less than a majority of Caucasians. Okay, so we can do then, so we have the same changes across years and grades. So now we have to select, so we're going to do the white freshman, so we can put like a clustered graph. Let's go back. Now, here we go. We're going to go to data, I want to select cases, and we're going to look at freshmen again. Okay, so we just look at the syntax as we're selecting cases. And then we're going to go to graph, error bar graph, clustered error bar graph, define. Okay, we've clustered because we're looking at 2 things now. So now we're going to look at 4-digit year of survey, the category. The clusters are going to be ethnicities. And the variable, which I forget, is BMI. Body mass index. Okay, so we have race, year, body mass index. Okay, and these are for freshmen. It's kind of a mess, and because there's a little bit too much information on this graph. So one of the ways to make a graph that looks like this that's a little bit better to look at is a line graph. So we're going to go to line graph. A multiple line graph with exactly the same thing. So we're going to change it to BMI, our body mass index variable. We're going to define our clusters by 4-digit category is going to be 4-digit year of survey, so each category. And the clusters are going to be by 4-level race. Defined lines. Each line is going to be a different ethnicity. And then we get to see something weird's going on in 2009. But you can get a general picture of what the trend is. And you can look at overall who's heavier and who's not. But again, this is for freshmen. Okay, so I'm going to copy this. Okay, I'm going to go to, oops, let's do sophomores. Having trouble. There we go. Data, select cases, if grade equals 2. Continue. As opposed to hitting OK, I'm going to click paste. This is something that, so now this is saying we're going to, data set 1, use grade 2. So then I have my line graph that I just made. I'm going to copy that, paste, and now I'm going to change this to 3. Nice. I'm going to hit paste again, and guess what I'm going to change it to? 4. So now, I just highlight this and hit the green button. It says run. And what it'll do is it'll select cases. And then we can see, here's freshmen. Here's sophomores. Here's juniors. And here's seniors. Wow. Okay, I'm not really excited, sorry. Can't fool it with the face on there.